What is up, everybody? In this video, we are going to learn how to use an RGB LED. An RGB LED has 3 analog inputs that enable us to control red, green, and blue light. By sending an analog value between 0 and 255 for each color, we can mix the 3 colors to make new ones. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our basic setup circuit that we made in an earlier video. Hover over the circuit and click on the gear in the top right-hand corner. Select Duplicate. Click the name of our circuit in the top left corner and change the name to LED-RGB. In the components, select an RGB LED and place it on the breadboard. If you hover over the 4 terminals, you will see that each color has a terminal as well as a cathode. Connect the cathode to ground with a black wire. Similar to other LEDs, we need a resistor. However, we need one for each terminal. Select a resistor from the components and connect the red terminal to another strip on the breadboard. Change the resistance to 220 ohms. Next, connect a wire from the resistor to a pin on the Arduino with a tilde. Remember, we are sending an analog output, so we need a pin that is capable of pulse width modulation, PWM. Repeat this process for the green and blue terminals. When complete, our circuit is done. Next, we will add code to control each of the red, green, and blue terminals. Click on the Code tab and ensure the text drop-down is selected. Fill out the information in the header of our code. Update the program name and description. The program name is LED-RGB, and the description is a sketch where we will control an RGB LED using an analog output. Declare the variables. Since we have 3 outputs, we will need to create a variable for each color. Create variables for the pins. Type int red pin equals 9, semicolon, int blue pin equals 10, semicolon, and int green pin equals 11, semicolon. In the setup function, tell the Arduino that each pin will be used for output. Type pin mode, open bracket, red pin, comma, output, close bracket, semicolon. Pin mode, open bracket, blue pin, comma, output, close bracket, semicolon. And pin mode, open bracket, green pin, comma, output, close bracket, semicolon. To control the color of the LED, we send a value of 0 to 255 to each color, 255 being the full brightness and 0 being off. In the loop function, type analog write, open bracket, red pin, comma, 255, close bracket, semicolon, analog write, open bracket, blue pin, comma, 255, close bracket, semicolon, and analog write, open bracket, green pin, comma, 255, close bracket, semicolon. Click Start Simulation and you should see a white light. Click Stop Simulation and try different values for the 3 lights. This might be a good time to open a color picker on your computer and compare mixing RGB on your screen with the LED. One thing to note is that when you enter low values, like 0, 0, 0, the LED turns off. It does not produce black light. Great! Let's look at how we can clean up our code to make it easier to work with. Having to write analog write for each pin gets a little annoying. It'd be great if we could write one line of code that would control all color values. We can do this with a custom function. This is where writing a custom function is useful. We have a repetitive task that we want to make into a callable function. So how do you create a custom function? The guidelines are actually right in front of us. If we look at how the setup and loop functions are written, this shows us how we create our own function. We write void, then the name of the function, followed by brackets for any parameters we want to pass to the function, and then curly braces for the code that will execute. Let's try it out. Below the loop function, type void Rgb, open bracket, int red value, comma, int green value, comma, int blue value, close bracket, open curly brace, close curly brace. We have created a new function called Rgb that accepts three parameters, the red, green, and blue brightness values. Next, we need to add some code inside the function that will execute when we call the function. Cut the analog write functions from our loop and put them inside the curly braces. Replace the numerical values with the variables for the parameters. When you replace the values, ensure that the correct color value is associated with the correct pin. So green value goes with green pin, blue value goes with blue pin, and red value goes with red pin. Great! Now we have a function that we can call, and it will change the color of the RGB LED. Let's try it out. In the loop function, type RGB, open bracket, 255, 255, 255, close bracket, semicolon. So the name of the function followed by the parameters. This is similar to all the other functions we've been using so far, except we have a custom function that accepts our custom parameters. In this case, we are sending a value of 255 for red, 255 for green, and 255 for blue. Click Start Simulation, and you should see a white light. Click Stop Simulation, and try adding some delays and calling the function with different parameters after the delay. When you test your circuit, you should see the RGB changing colors. Cool! Being able to write custom functions gives us another coding tool we can use with our circuits. You could also look at how to provide the color values to the RGB. For example, these could be tied to an analog input like a potentiometer. When you build this circuit, double-check the pins on the LED. When I built mine, the green and blue pins were reversed compared to what was used in Tinkercad. At the end of this video, you should have a better understanding of how to control an RGB LED and how to write a custom function.